Hello again. In this video, we shall try to analyze and dry run this particular program using physical models or physical objects. As we agreed, this is an example for loop implementation, repetition. And we have agreed that repetition is implemented using the keyword while. And there must be a condition for which repetition will be done until when the condition is broken, then that particular loop is broken. In this case now, we have standard lines include, those are libraries, they don't matter, but the program starts here, int main, and it is starting from this curly bracket ending here. Now, int I is declared and it is initialized with the value of 1. That's why you see int I equals 1. I is reserved and it is given the value 1. Int n is reserved and it is given the value of 1. When the computer comes at this line, while I less than 5, the condition starts to check. Do the following. That's n equal to n plus I equal to I plus 1, only when I is less than 1. So, in the first instance, the computer will come to check in I, and once it finds that in I there is only 1, and since 1 is less than 5, then the following will be executed. In n, there will be an addition of what is in I to what is in n. So 1 which is in I will be added to 1 which is in n, and then I will be incremented to 1. Now, n which had 1 was added by 1 which was in I, so in n there is 2, but then I was incremented by 1, that is I equals to I plus 1. 1 which was in y is increased by 1. For now, we have 2 in I due to the feature of this particular statement. Now, the loop will not end because the computer is coming to compare. While I less than 5, in I there is 2. Is 2 less than 5? Yes. Since 2 is less than 5, the loop will continue. N will be equal to n plus I. So, the content of n will be incremented by the content that is in I. That means that in n, 2 will be added to 2 which is in n, so that now n is going to have the value of 4. Then, after n is given the value of 4, then I equals to I plus 1. In I, there was 2, and 1 is added in I. Now I is equal to 3, and the computer now is going to check. While I less than 5. Is 3 less than 5? Yes. If that is the case, the loop will repeat again. N is equal to n plus I. The content of n, which is now at 4, is going to receive the content of I, which is 3. And for that matter, we shall find that in n we are going to have 7, while in I there will be 4. Now, as you can see, n has accumulated to 7, while I is only having 4, and the computer will check. Is 4 less than 5? Is I less than 5? Yes, 4 is less than 5. So the loop will repeat. N is equal to n plus I. The content of n will be incremented by the content in I, and the content in I will be incremented by 1. So 7 in n will be incremented to 4. That 4 in I will be added to the 7 in n, and n will have 11 as the content, while I is going to have 5 as its content. Now, the content in n is 7 plus 4, that is 11, while the content in I is 5 due to incrementing 1 on 4, and the computer will check while I less than 5. In I there is 5, and 5 is 5 less than 5? No, 5 is not less than 5. So this loop here is going to break, and the computer will jump to this instruction, C out N, C out I, where we shall see 11 on the screen, and we shall see 5 on the screen as the output of I. So we have been able to visualize the behavior of the computer when the loop is being executed by using these physical models. Thank you for everything.